hardware vendors have been doing so far? Well, that's in the past. First, they were just selecting a kernel version and sticking to it as long as possible and piling patches on top of it. And when they were ready to share their kernel, they would just send a big tarball, like a big tarball to the people with everything merged into the kernel, all the changes, so you cannot make any sense of what was in that kernel. It was a big blob of sources. So if one wanted to extract the difference between mainline and this kernel, you had to produce a diff, and most of the time the diff was like 20 megabytes compressed. It was really huge, and nothing that you can extract any difference from the mainline, so you cannot assess what has been done by vendor. And at some point, people were looking for new features that were available in the later kernels, so they would just backport all kind of stuff into that old kernel. So you would have mixed up between hardware support and generate features that were available in the latest kernel. So for distributors, this was really a big pain because there's no way to review the kernel to make security enhancements and just do the maintenance with all the features that distributors want to add themselves. It was quite impossible. And even for the vendors themselves, if you want to add new features or forward port your kernel to the latest version, and you have this big mess of all your changes mixed up with an old kernel and backward of new features, it's fairly impossible. So hopefully that was ancient history. So what people have been doing more recently is to keep those changes separate into patches. So what we have is still an old kernel with new patches added on top, stored in a CVS tree or a SVN tree or whatever people are using kill, but usually it's or even a Git tree. But the thing is, you have this old kernel with like hundreds of patches added to it. And at some point, I've even seen that one of the patches would be backward of Linux 2.6.32 on top of Linux 2.6.21. So that one patch would be a huge patch, which was the difference between 2.6.21 and 2.6.32 in mainline, which was applied on top of what was already there. So you have your 100 set of patch, then this huge patch to bring new stuff from the latest kernel, and then continue adding patches on top of that. While this is a bit better, it's still a mess, because then you have a set of linear patches with a big gap, a big step in the middle, through which you cannot forward port your patches easily, because the first patch at the bottom of the stack cannot be forward ported to the latest kernel without having to cope with all the changes that happens in the middle. So I think that's how people are working right now. It's better than having a single togbar, but it's not that efficient yet. It could be better. What we have to do proper kernel workflow are some tools, of course. The first tool that came to be to solve that problem was Quilt. So people know about Quilt here?
Yeah.
So quickly, the idea behind Quilt is to apply a set of patch that you can pull, push, and pull on top of your vanilla kernel. So when you want to move ahead to a new kernel, you just pop all the patches, switch the kernel underneath, and reapply all those patches. And Quilt was really nice to record changes that you have to make to your patch when applied to your new kernel, and you could reorder patches, you could merge them. It was really nice, and some people are still using it today. So if you are maintaining a kernel in your company and you want to have some sanity into it, especially to follow what's happening in mainline, Quilt is probably a good tool, which is simple enough. But the problem with Quilt is that it's probably meant for one-person workflow. You cannot share work with other people. Or, well, people might make patches, but there's one person who's maintaining the queue of patches. And it's a bit harder to distribute that work because you can publish your set of patches, but if people want to work on top of your set of patches and you happen to reapply it onto a different kernel, then it might cause problems because the patch won't apply anymore, and it's a bit harder to collaborate with many people in that workflow. So then we have Git, which is probably the latest in kernel management. What Git offers is distributed workflows. The thing behind this is that you can fork branches within the same repository or amongst different repositories which are remote from each other, making parallel development possible. So with Git, it's really fast and efficient to branch your workflow into various directions and merge everything together afterwards. The idea behind Git is to be able to distribute the work amongst many people. So people are starting from the same fork point or various fork points, it doesn't matter. And then you can, on your own side, work on your set of patches in your own branch. And at some point, merge everything together. Of course, this also allows people to ask for only part of the branch, or only a small set of branches to be pulled into mainline at some point. You don't have to have this big linear patch stack to make sense of some subsystem or some driver. You can work on one driver based on mainline and have that driver develop independently of everything else. And you can have it merge into mainline by itself, asking the driver subsystem maintainer to pull that driver alone, and so on for every part of your patch set. Any questions so far?
On the details. For example, the typical problem I have is cross-subsystem dependencies. But I guess that's a separate chapter, so maybe we should handle it later.
Yeah, well, it'll come later. We can make it really complex if we want to.
Yeah.
So, since we're talking about Git, I won't talk much about Quilt because Quilt is quite simple. If you want to use it, that's fine. If you have a bigger organization, it's probably not that tool, but it can be used. Some people are still using it. It's easy to learn, so I won't expand much on this.
Does anyone here use Stack Git?
Used what?
Stack Git. I think it's designed. I think it's designed to be sort of like Quilt.
Yeah.
And you manage a stack of patches. You know how it works. I think capture.
So stack-git.
Yeah, or I think they're all ST. So you can convert your stack back to a Git branch. So it's kind of like Quilt, but I think you can do the share.
It's kind of cross between Git and Quilt.
Yeah.
So is Kernel using this to...
Or maybe resistant. I think it's probably actually quite good.
Well, that's what he used to queue up the R patches.
Yeah, yeah.
Okay.
Yeah, it's probably a hybrid solution between Quilt and Git. But what I'm I'm going to talk about is giving you tips how to use Git, all the power of Git, which might, after a while, it's not necessarily clear in the first one, but it's really, really powerful, and you can do much more than linear patch as we did. So, okay, let's start from the beginning. I'm just following my notes. The idea with Git is that you can have small changes that you can apply to various commits. So as soon as you have something worth committing, just commit it. It might be not pretty, it might not be final, but it doesn't matter. Commit anyway. So you can have many commits for very little things, and after the fact, when everything is done, there are tools to combine those commits together, or reorder them, or even merge them together. But the first thing you can do is commit anyway. If you're going to go for lunch, commit. That's the best way not to lose your stuff and make sure that you know what you did. The commit log might hold notes that represent your thoughts of, I just did this and I still have to do this. The tool is there for you. If you want to apply new changes to the same commit, there is commit -- amend, which allows you to reword your commit log or even add new changes to the same commit as you committed before. It's really handy. The second thing you can do, I use it a lot, is commit -e, meaning edit. That allows you to commit only a part of changes that appears into a file. So, if, for example, if you have local hacks and you want to keep them, but you don't want to commit them, you just do commit -e, and the editor will pop up with the diff, and you can just edit the diff inline. Delete the line that you don't want it to see committed, and Git will be smart enough to recompute all the hunks, number, counts, and everything, and apply only the changes that survive into the diff you have in your editor. There is also Git. With Git, you can also add the rebase command, which is really, really powerful. Because if you use rebase -i, meaning interactive, you then have a list of all the commits you have from the starting point you gave it, the commit. And then you have all that list of commits, you can reorder them, you can merge them, you can edit them. There are a bunch of commands that you can put in front of the commit name that you have in your editor. And all those commits might be still in the same branch, or you might reapply them onto a different branch. So if you have many small commits that are not necessarily pretty, and after, I don't know, after 20 commits, you realize that you have a bug somewhere, 15 commits behind, doesn't matter. Just create a new commit on top that fixes your commit that's been broken before. And with commit rebase -i, you can just reorder them and merge that fix into the original commit that was broken initially. If you want more information, this is not a tutorial, so if you want more information about rebase, the Git manual page is really detailed about that with example and ASCII art drawings to show you what's happening there. So for more information, just look at the man page for Git rebase. No questions so far? Okay. Later we'll see how we can apply this for actual kernel maintenance. Of course, with Git might be threatening because it's quite powerful. The learning curve might be a bit harsh at the beginning, but don't be afraid to try out things. It's really, really hard to lose data with Git, because everything you do is recorded in what we call the ref log. So the ref log is a pointer to your repository state at any moment you're doing something. So as soon as you modify the repository state, there's a new ref log entry for it. So if you delete a branch, if you completely mess up your rebase or whatever, your previous state is there and it's really easy to get back to it. So don't be afraid, try out things, and if it doesn't work the way you wanted, you can go back, there's no problem. And even if you screw up your going back, you can go back to the go back. Everything is recorded there. Okay. So let's get into actual workflows. With Git, if you have multiple subsystems in your BSP, it's a really, really good idea to split it into as many topic branches as you can. Because if you have those small branches, it's much more easier for people to review them, and it forces you to have those things with as little interaction between each other as possible. So it forces you to have good abstractions between all the drivers, and then cross-dependencies between branches should be minimized as much as possible. The side effect of that is that your code will look better. So for example, if you have your core stuff, for example, basic SOC support with all the header files, this can be done into, let's call it the core branch. That branch, from that branch, you can fork topic branches for, let's say, the audio driver, for the graphical driver, for whatever. Anything that can be split into its own branch should be split. At some point, if you want to test everything together, it's really easy to create yet another branch, which is, let's say, the integration branch, where you will merge everything together just to test if everything is working together into a single test branch. That branch is where you will find your kernel for compilation and testing on the actual board. But since this is an integration branch, this is not the branch you should develop on top of. It's only a throwaway branch that when you're done, you just delete it and you're done with it, because development should still happen on all the sub-branches you have for each subsystem. Now, if you want to follow mainline, because that's a really good idea to follow mainline, of course, you can have all your sub-branches be rebased on top of the latest kernel, or even on top of the latest subsystem branch into one of the subsystem maintainers. It's probably better if you find a subsystem branch which is stable, meant to be merged into mainline, so you won't have problem rebasing with something which is not stable, but it's still possible to rebase stuff on top of an actually rebased branch already. If you look at the rebase documentation again, there are examples of workflows with rebase. So, for example, if we're moving from 2636 to 2637, it's a good idea to pull 2637 into one of the remote branches, and then just rebase all your branches one by one on top of 2637, and then redo the merge branch, integration branch for testing afterwards. Advantage of this is that whenever you have your rebase command applied on top of a branch where some of your patches have already been integrated, rebase is smart enough to drop those patches which are already merged into the branch it's been rebased on top of. It'll do it automatically for you. One thing which is also available with rebase is the dash onto, which allows you to transplant branches from one trunk to another. So if, for example, you want to move stuff around, you think that your branch are not laid out correctly because dependencies are in the wrong way around. You want to have stuff which is generated at the trunk and subsystem branches forking from that point. You can rebase those branches and change the order of what branch goes where. It might get a little bit tedious at first, but after a while you really get used to it, and that's not something you have to do often anyway. But I just want to let you know that it's possible to do. For example, when I developed the security patches for the linear tree, at first I was developing them on top of the linear stable tree, but since the linear stable tree is not meant to be merged into mainline, I just used rebase to transplant that branch onto the vanilla kernel tree for Russell to pull. So it took only 5 seconds for Git to move all those patches around. It's really quick. So those are tools that you should really try to master because it makes your life so much easier afterwards. One thing that can happen when you merge your integration branches all together is you might have conflicts between all those branches, because when a branch is developed independently from the others, you still want to compile test it. So you might have changes that conflict one with each other when you bring everything together. So because we want to have an integration branch which is merged and thrown away, let's say each time you want to do a test build, it can become cumbersome to fix the conflicts manually each time. So what Git provides is the re facility. Probably means reapply I don't remember what it meant. Reapply previously resolved resolution. I think that's something like that. So if you do in your configuration, Git configuration, you just have to set some configuration variable to true. I don't remember which one at this moment, but the man page will tell you. As soon as you have a conflict, it will notice the files that are in conflict. Then you can start the graphical merge tool or whatever tool you want to use to fix the conflict. And then this re thing will remember what you did to solve the conflict. And the next time the same conflict happens, it will solve it automatically for you. And if you don't have fear, you can even turn another configuration variable on. So it will apply and commit that conflict resolution automatically for you. Yeah. Maybe by default you should look at it, inspect it, make sure everything is fine, the conflict resolution is okay, but after a while, if have confidence, you could just turn that option on. Especially if you want to do this integration branch automatically out of the script, then it might be handy to have as much as possible be automated. Any question?
No, sir. Oh, well, the workflow that
I was using the captain who did the LDE stuff, that we would both be working on a shared common branch. And that would be alright until one of us decided to rebase it to go back to 0. And then you'd have to do some magic rules with the ref on and rebase onto the other guy would. But if you push some stuff in the middle, then it would get lost. So we had some horrible system for pushing a commit called lock, and then some horrible scripts so that you can, and that's not going to scale. It worked for 2 of us. Is that what we're doing wrong?
We pretty much realized that if you share the branch with somebody, don't rebase it, because you're going to lose all the backend history in this code.
Yeah, that's right. That's okay if you write everything correctly first time. But
Yeah, sure.
But at the beginning, you might want to rebase because when you're developing, you want to commit all small changes, and with funky log messages, doesn't matter because you know you're going to clean up after a while.
yeah, I mean the latest Git has some. You can put fix up
Yeah.
exclamation mark commit, but rebase will automatically use that later on. We do that, but then say after a week we've got a whole load of crap.
But for example, if someone is upstream of you, let's say Kernel was upstream of you, you could just, instead of pulling his new stuff, which would do a merge, and then if he's rebased his branch, you will get a mix of the old thing and the new thing. So you can do a git pull -- rebase. So it'll figure out automatically at what point in the old branch you fork from Kernel and reapply on top of his new branch, which has been rebased. So of course, if you start to pull each other, then it becomes a bit more complicated.
Yeah, I think the problem we both had push access to the shared branch. We both pushed up at the same time. One of us rebased and the other guy pushed. Then changes would get lost.
But of course, this is a tool, right? So it doesn't replace human communication. So you need to figure out with your team, well, okay, we're doing integration branch every Tuesday or every second day. So that's something that you have to establish with all the people involved. When you're only 2 people, that's not that bad.
No, it was actually fairly workable. It's just if it scaled to a
Yeah.
big team, I don't think it would work.
But if you're a big team, I don't think that a big team will all work on the same thing. Because you cannot have a team of 15 people working on the order driver. Same thing. But at some point, you have to split the work, which is manageable, and that people can be independent in their own branch as much as possible.
We should add something there about, for a large company like ours, we have several hundred developers, and they're actually developing all of them against the same development track. So in order to facilitate that, the typical solution at ours and many other companies is to put Gerrit in place, this Google tool. And what Gerrit does is that actually you pull out the trunk branch, you apply a number of patches, and then you submit it to the review system, and then there is some code reviewers on who make submit, and then he cherry picks especially that change and put it on the development branch. So everything gets stacked on top of each other. So the concept of topic branches in Gerrit is totally removed, and it's a side effect of using that enterprise tool. It just kills all these powers of Git of using topic branches.
You kind of have to change history.
No, if your company decides to use that tool, you're more or less hijacked by it, and the trunk development you cannot really influence. And often we have a code management department which is really infatuated by this tool, and the story goes on from there. You can sort of see the picture. So what we're doing with Linara is we have to, break it apart somehow. Make our own management for upstream stuff, and that's as far as we can go. The main development will go on in that tool forever. So I don't know how to. It's a social problem, or an organizational problem.
Because if your goal is to merge your stuff in mainline, you don't have the choice. You need to have separate branches for separate things, and you need to follow mainline.
Yeah, indeed. So the big company reacts to that in saying, okay, we will do this, we will defer the mainlining tasks to a special committee or a group of people who will do that. And that's what they always say. And it's a real bad idea, of course. The real answer would be wipe out Gerrit, use Git as it is, create a subsystem hierarchy of like the community has, or something like that.
And one thing you can do in corporate setting is to distribute the responsibility of subsystem. So instead of having everything go through one review instance and someone at the top say yes, no, you can have people responsible of their own subsystem.
Gerrit supports that. So you have this, but the problem is that it doesn't use topic branches. So if you don't, pardon?
Gerrit, sorry, can you spell that for me?
Gerrit.
Yeah, it's been developed at Google.
Yeah, it has been. And it basically assumes everybody's working on it. You can have several branches, but the way most companies are using it is just making one big branch for everyone.
So I know some people who pay for similar problems, maybe they do git format patch and then commit to patch to some of the version control system. Sit there to it.
The same problem is what's wrong with having Gerrit or 8 different topic branches in one final automatically integrated by buses.
Yeah, that's possible. I guess that's a question for the code management department. Most companies have everything set up this way that they have one big integration branch. And I think it's out of habit from the old ways of doing things.
Because it comes from all the history from CBS and all those systems that somehow supported branching, but it was so painful to use that practice didn't support any branching at all.
But Git supports branches, but it doesn't support rebase or merge.
Yeah,
Gerrit.
Okay, well, sorry, Gerrit. Gerrit, you can use your topic branches in Gerrit, but Gerrit cannot record if you did a merge or rebase between your topic branches.
So you will
That's exactly what
So even if you use Gerrit to maintain like the review system for all the topic branches, you still need a person to go into that eventual repository and sort of integrate stuff together to make this testing point. And to do it rebase as a developer is not possible, and then you lose all the power of Git. So actually,
But if you produce all the topic branches and you will manage the reviews in Gerrit, but you cannot put them together and make that visible in Gerrit. But at least one person for maintaining, for instance, you can take all the topic branches and you pull them, or when you rebase them
It
into
can be
your...
done outside of Gerrit, I guess.
yeah, it can. The problem is with Gerrit, with the Git servers, the code management department that every company has are very strict about it. It's a way of for them to exercise control and feeling this power rush and so on.
That becomes a political problem.
Yeah, it becomes a political problem very quickly, and it's yeah.
And I'm afraid that no tool might solve this problem.
No.
But I mean, we have one integration department that handles all our products, but you're not interested in products, you're interested in the generic code. So you could hijack all the topic branches from our generic development and then make an upstream version of it. I mean, then it would be the product department's issue when they see that they don't match.
The problem with that is usually the product department gets priority because that's where revenue comes from.
Yeah.
So from the start, it's much better to try to have topic branches from the beginning of the development cycle, instead of having this mentality of we rush everything to have this product ready and we'll clean up afterwards and it happens.
Yeah. And it goes political.
So of course it requires some social engineering
Yeah.
that the tool cannot fix. Okay, so if you want more information about all those workflows, a lot of documentation is available online. There is the Git-SCM website with a big wiki and reference to all the manuals and books that have there are, so if you have distributed work between different offices, for example, you can have public hosting of the repositories, and some of them are offering private repositories as well, for a fee, of course. But if the infrastructure is too costly to have inside your organization, because, I don't know, let's say IT is too overloaded, so for a small fee, it's possible to have a private repository. So I think that's all I have.
So Linus, your question about cross dependencies, we haven't discussed it.
Now, cross dependencies between subsystems, that's an interesting topic, of course. The basic problem is something like this: you're working on a graphics driver and you're passing platform data into it, and then you start altering the H files for the platform data down in the core architecture. And somebody else is rearranging the core architecture in some funny way.
Or the graphics relies upon I2C or something like that.
Pardon?
The graphic system relies upon I2C or some other bus.
It's just some platform data.
I think we sort of covered that, because in your integration branch you get the same content on
Yeah.
so the read thing can be used.
Yeah, may be a...
Provided these changes aren't, I mean, chances are, I guess, it's going to be the same.
You can have that to carry along with the old version until you decide to just rebase on top of the new core branch.
No, exactly. Then when you want to bring that to the community, you find another very interesting problem. That you have to get to Russell and Samuel Ortiz and such guys to cooperate on who's going to take which patches. And that's actually a real problem.
Yeah, so that's a problem, sure. So if you can work around it from the start, let's say if you have header files, those are pretty independent. So you can have your header files and your data structure declaration into the core branch that goes through, let's say, through Russell, and afterwards you branch your drivers and stuff like that.
Yeah, exactly. Well, the problem is in the merge window, and Russell always has to go in first, and then the others have to follow.
Yeah.
But it's more or less like that already.
But how it's done so far in the community is that you can have the subsystem maintainer add your patch, and then have those patches through Russell or Linux or whatever.
Yeah.
With the subsystem maintainer agreeing to that.
Yeah, mostly that works. And then you get into an even hairier situation when you have things are already queued up in Russell stack next. And those things conflict with the stuff that you're bringing into the other subsystem. And then the way we've actually resolved it is that whoever hits Torvalds repository first wins, and then the other subsystem maintainer apply a fix-up patch. Russell always wins, so then the others apply fix-up patches that are carried by Stephen Rothwell. And it works pretty well actually.
Yeah.
As long as they are willing to cooperate with the Rothwell and sort of bring his fix-up patches at the right point before issuing their pull requests.
But of course, with Git you can experiment the merge yourself. You just create that test branch where you merge all those things together before it's been merged upstream. You have this the exact same result as what we'll get into the Linux tree. So at this point, it's easy for you to figure out what would be the conflict if there's one, and what is the conflict resolution, and have the resolution ready for people to use it. They are aware in advance that there will be this conflict and you fix it this way.
Yeah. And we have had even worse, I think, conflicts. So, for example, if you want an external display to be turned on, you need to have some platform data in place in Russell's tree. You need to have regulators in Samuel Ortiz tree. You need to have the I2C communication in David Bromell's tree. And then that driver into the frame buffer tree. And at that point, actually, the time it happened to me, I just gave up and merged some things in the first merge window and then wait for the next. So sometimes you actually have to give up. That's my experience.
Yeah, but that's one example where you can just have your patch review, have the subsystem manager act them, and you explain those things that people are pretty good.
For two subsystems cross dependencies, that's pretty okay. Free.
Well,
more.
well, even if it's 4 subsystems,
Yeah.
you need to have those 4 people review your patches. So whether or not they merge them afterwards, it doesn't matter. As long as they've reviewed it and they act them, you can just put them together into your own tree and decide who's going to pull them.
Mostly that actually works.
About 1 minute, right?
I think one thing we didn't cover, because we haven't got time, is git bisect,
Right.
which I've always had quite a painful experience where if you hit the merge window trying to bisect that, you end up somewhere in the middle of 0 as a build. I don't know if anyone has any magic tips for using it.
The word that verification quantity is some basic.
Yeah, but often it's not your changes, you can bisect it.
You could have git k dash bisect, I think, and you're able to visualize graphically all the branches, and then you can pinpoint between which point you want to this bisect. But there are things that allow you to view in graphical form all the branches and all the interactions between them, and then decide where to start or who to stop. I think that's git k exercise.
Git K always scared me. It's a weird version of Yonder.
Yeah, but you can confine it to some commits range. You don't have to have the whole thing commits. It's a git k 2635 .2635 36 RC1 or something like that to restrict it.
You can also try limiting bisect to just a set of files or directories. Directories contain those.
Yeah, it depends on the nature of the problem.
I think we're out of time.
It's rubbish.
Guess what the snack is? Guess what the snack is this morning?
So I hope it was useful.
Oh, well, that's really good.
So if you have any other questions, just email either to me or the Git mailing list, which is quite friendly, actually. If people are used to the kernel mailing list, the Git mailing list is more nice. People are just so happy to have you there.